I think the first one is quite okay lah. We just do it together. For an expression of un, so un is Sn minus Sn minus 1. You're given that Sn, this is actually Sn. So first one, it'll be um Sn minus Sn minus 1. Okay, that's about it. So Sn is given by an square. So this is a n square plus bn minus of a n minus square plus bn minus 1. Going to issue an square plus bn minus an square minus 2n plus 1 plus bn minus b. Okay, then you just slowly expand it. I think should be fine. An square minus 2an plus a plus bn minus b. So just expand this. This will cancel with this one. So what is left behind is 2an minus a plus b. There's your un. Then for the second part, you are told that the tenth term is 48, so u10 is 48, and then the 17th term is 90. So just gonna solve this. So part 2. So u10 is 48, and then u17 is 90. Shouldn't be an issue. Just use what is given previously. So 2a times 10 minus a plus b equals to 48. Then 2a times 17 minus a plus b equals to 90. Okay, and this is 19a plus b equals to 48. Then 33a plus b equals to 90. This is just typical SOLE. So solving 1 and 2 by GC, a equals to a equals to 3 and b equals 9. B equals to minus 9. Okay. For part B, quite okay. I think this is secondary school stuff. Now, I do not know how do you do this. A lot of you would think about expanding, but I keep saying this, right? Factorizing is more superior than expanding. So try, before you factorize, you try before you expand, you try and factorize first, okay? So even for this case here, your first intuition is to factorize, I understand. But, I mean to expand, I understand. But if you can, you see if I were to factorize, right, it'll be much faster. With left hand side, r square r plus 1 square minus r square r minus 1 square. So you just factorize it out. R square, maybe r plus 1 square minus r minus 1 square. Then this one is a square minus b square. So you still can factorize the difference in squares. So it's r plus 1 plus r minus 1, r plus 1 minus r minus 1. Okay, so maybe I'll write this down for you. This part here. So I factorize this out. Factorize r square out. And here to here, a square minus b square. A minus b. Okay. So this is how I will do it. That will be r square to r. And that will be 2. So very naturally, this is 4r cubed. Okay, not an issue. So you want k, right? K would be hence 4. So for the subsequent part, which is you try and see this one here, simplify this. Now remember, for summation, if you're stuck like that, right, understand, it's either AP, GP, or MOD, at least for the direct one. Okay, so this cannot be AP, GP because AP is a linear, this is not linear. GP is exponential, so this is not exponential. So essentially, this is a method of difference. So if you, this is how you think when you're in exam. For summation, it's quite standard. There's only AP, GP, or MOD. Okay, so that's what I'll suggest. So this is AP, GP, or MOD. Now this case here, so MOD will be these two terms. So if this is UR, this is UR minus one. Or not? Right? If this is UR, that's UR minus one. You can actually see that. Okay, so this case here, you want to express this. So usually what I'll do is I'll write in a in a equation form. I don't really like to write so I write the whole equation down, this whole thing down. Okay, so write it down, use this result to find. So I'm going to write it down. R square R plus 1 minus R minus 1 for R cube. So what I'll do is I'll just attach a summation in front. R equals to 1 to N. This whole thing. Okay. Then you just do this MOD, not an issue. So you can just let if you are lazy like me, right? I'm going to let UR equals to R square, R plus 1 square. And then this will imply that UR minus 1 equals to R minus 1 square, R square. Okay. So if you're lazy like me, I will just do this. Let it be UR. Then for the other side, this is what I want to find. What I want to find. Okay. Then I'll just U1 minus U0. Just MOD. U1 minus U0 plus U2 minus U1 plus U3 minus U2 all the way to the last one. Then there will be 4n equals to 1 R cube. There you go. U0 UN was n square n plus 1 square U square. Here you go. Can you just key in calculator and check your answer in exam? Please key in. So this is how you key in to check. Just key into whatever you found here. Just make sure for summation you can use your calculator and check your answer. Okay, so you just key this in. So key this in. Remember, can use a calculator to check. So this is AR to 1, and this is N, which is X, and R cube. So this is R cube. Then the next one will be, you just key the next one, 1 over 4. Then that will be 4. Is X squared, X plus 1 square. Okay, so that's it. You just second table. So I would use I confirm in the exam, I would definitely check your answer. So as long as both would tie up like that, means your answer is correct. Okay, so just remember, for summation and APGP is very nice because especially for summation, you can actually check your answer using calculator. The Lambert ratio test. Now these are kind of questions with exam, right? Just be chill about it and then try and see whether you can think just slowly. Just leave it to the last, okay? You need time to think about it because it's not straightforward. So this Lambert guy, just read the ratio test. So this is a test, okay? A series of 0 to infinity AR converges when the modulus of an plus 1 over an is less than 1 and diverges when it's bigger than 1 and equals to 1, then his test is inconclusive. Using this test, explain why it converges. So essentially, you need to show that, so essentially, if AR converges, right, when limit n to infinity, an plus 1 over an is less than 1, then diverges when limit n to infinity, an plus 1 over an more than 1. Okay, then inconclusive when is this lah. So that's pretty much. So we just want to show this. So the whole thing in front, right, just need to show this only. That's all. Okay, now let's try to understand this. Now, I said before, and I'll say it again. Whenever you see an, right, and an plus 1, you need to know that they are neighboring terms. Okay, they are neighboring terms. So what you need to do is, if this is the current term, then this will be the next term. Okay, then if this is the previous term. Now take note of this. If n goes to infinity, you are taking the ratio of the next term. You see this as, to test this, right? This an plus 1 in particular, in over an, is actually the next term, the modulus of the next term over the current term less than 1. Okay? Less than 1. The modulus of next term of current term less than 1. So what can you deduce from here? Obviously, you know that next term would be the absolute value of the current term is bigger than the next term. Make sense? So essentially, if you think about it, so it makes sense, right? Because if the next term divide by the current term, if it's less than 1, I can expect the next term to be smaller. So if the next term over current term is bigger than 1, I can expect the next term to be bigger. So essentially, it will only happen when the modulus, meaning the height here, is smaller. So this would like render it to be a convergent sequence, right? That's the whole idea there. So understand that you are looking at it. Then how come modulus? Modulus because you're looking at the absolute value. Essentially, some sequence can be like alternating. So it can be like positive, then negative here, then positive like that. So some series can be like that. Okay, so like this is an plus 1 is an minus. Okay, it's just generally that's what you're trying to say lah. So try to understand the equation there, then you try and deduce. So not difficult, right? Current term. Okay, so is it ratio? Can ratio test. So essentially we just want to show that the ratio of the next term over current term is less than 1. Okay, that's about it. So how? So explain using this test, right? Why it converges for all value, and then use this test also to find the value where it converges to. So let's try to do this. So for this expression here would then be r equals to 0 xr over r factorial. This guy is your AR, right? Because this is AR This is AR. So this guy is your AR. What you need to do is so hence let AR equals to AR equals to XR over R factorial. So this case here, what you're gonna do is find the ratio of AR plus 1 over AN. Okay, just find this first. So this is what you need to find. Examine let AR XR. So then this case here, what we get is actually an plus 1, which is actually xn plus 1 over the bottom would be like that. Then what we're going to do is just simplify this. Shouldn't be an issue here. So factorial is very fun to play. Remember, you need the modulus. So xn times x over n plus 1. Okay, maybe I shouldn't do this. I just xn plus 1 over n plus 1. Okay, so for factorial, always choose the bigger one because the bigger one contains the smaller one. Okay, so you just choose this one, the expands. You know that n factorial plus 1 factorial is n plus 1 n factorial. Okay, so what you're gonna do is actually just xn plus 1 over you just cancel all this. Then you just try and yeah. Then this will be modulus x over n plus 1. Okay, is it alright? Yes. Because they say limit n to infinity, right? So you just this is a. Do you remember this is a so hence a n plus 1 is okay since x is an arbitrary constant. In this case, it's arbitrary constant, so you will have as n goes to infinity, x over n plus 1 goes to 0. Okay, so this will be 0, which is less than 1. So by a Lambert's ratio, so by since I don't know how to pronounce his name. Ratio has x r infinity converges for all real yep. State the sum to infinity of series in terms of x. Sum to infinity will be then you just write it down. Now, whenever you do not know what is the sum to infinity, you just write it down. So this is like x0 0 factorial plus x1 1 factorial plus x2 2 factorial plus x cubed 3 factorial. Okay. Now the series which the only place in your MF, right, which has a series like that is under the Maclaurin series already. Okay, so you just go and look around, just write down. Now, most important thing in the exam, even if you are clueless, right, write something or expand it and then try and figure it out. So in your MF26, you have this EX, right? This is EX. So you know that this is EX. Okay, so hence converges to